Welcome, everyone. And as the others are joining, I would like to welcome you for a webinar. And my name is Natalia. I'm the manager at the Renewables Grid Initiative, and I'll be the moderator for today's session. We are also joined by RTE and Trimet. But first, I'll start with a short introduction to our agenda. So before we hear from our experts on the specific practice that we have today, I'll give you a short introduction about RGI and why we are looking into circular solutions for power grids. Then we'll also hear from RTE, as I mentioned, on their best practice installing aluminium alloy conductors on the grid. Then we'll hear from Trimet on the challenges and opportunities for a circular aluminium supply chain. And lastly, you have the chance to participate in a discussion and really ask your questions and interact with our experts. So you're welcome to use the chat and raise your hand at the Q&A session, and we're happy to have your discussions. And just before we start, I just wanted to do a housekeeping guidance for you. So very importantly, this webinar is being recorded and will be publicly available in our website and our YouTube. So for that, and also to avoid any interruptions, please make sure that you keep your microphone off and your camera is welcome to stay on so that we can see some faces in the meeting today. Then we also welcome you to add your name and organization on the Zoom so that we can actually see who is joining us. And last but not least, as I mentioned, you'll be able to use the chat or raise your hand during the Q&A so that you can participate in the discussion. You can just use these two functions on Zoom. So without further ado, I would like to start with the introduction as mentioned before. Firstly, introducing a little bit of RGI for those who are not aware of. So RGI is a really unique organization which brings together transmission system operators and environmental and climate NGOs across Europe. And we really try to engage the different actors to enable power lines that are fair, transparent, and sustainable in line with the Paris Agreement and the decarbonization goals of the European Union. And looking into that, one of the main activities that we pursue is actually sharing experiences with replicating. So this is part of our best practice work, really trying to collect and talk about different experiences that grid operators or other actors are putting in practice and really inspiring new and innovative practices across the energy system. And this also goes in line with our RGI Grid Awards. And so basically we drive a lot of practices from the award, which is a specific award that really celebrates good practices based on a jury that evaluates the practices. And in our website, you can also look into the good practice database where we have different innovative practices available for you. And as a solutions-driven organization, we really focus on the implementation of grid infrastructure. And specifically, we try to foster knowledge exchange and discussions in three different dimensions. Specifically, we have a technical dimension, which is also the topic that we are dealing today, which really looks into how to model, plan, and implement a clean energy system that is optimized and also very inclusive. Another dimension that we have is energy and nature, which tries to incorporate nature and biodiversity within the energy system. And this last but not least, we have energy and society, which also tries to bring different voices into to the decision making and really trying to create this knowledge exchange. So looking to the topic of today within the grids and energy system dimension, why actually are we talking about circularity and supply chains, and why have we decided to start working with this and also start the webinar today? So as we have seen by my introduction before, but also throughout the work of RGI, electricity grids are extremely important for the integration of renewables into the energy system. And as we accelerate this deployment, components and equipments will be more and more needed. And here we have a joint research center study that really looks into the needs for cables and transformers, as you can see, until 2030. And this need will be only increasing in time. And then in turn, with these components and equipment, raw materials will be more and more needed, as well as the manufacturing capacity for them. And here on the side, we have ADA Group's 2024 study, which looks into how much raw material will be required for the different assets in the offshore context specifically. And you can see that this is one of the main takeaways from our work so far, is that the energy transition is a materials transition. So if before we had a dependence on fossil fuels, we now shift this to technologies, to components, and also the materials and their manufacturing. And on that side, there is on the supply chain side, we also have been seeing more and more costs from transmission components, which also impact the affordability of the transition and the grid deployment. So here we have also a study for the International Energy Agency from 2025. And you can see that power transformers and cables prices are increasing quite a lot. And in their study, they highlighted one of the main causes for that is actually the spikes of of material prices, and that's mainly what they notice is copper, aluminium, and grain-oriented electrical steel, which are key materials for the transmission grid components. And then at the same time, as we see different sectors decarbonizing and different technologies, but also sectors beyond the decarbonization, for example, on defense, we also see even more concerns on the supply chain and the keeping on the grid supply chain intact. And at the same time, we also see a lot of geopolitical constraints currently happening and also in the past. And all of this is even more dramatic when we look at the productivity of materials. So although material extraction has been increasing quite a lot, productivity has been historically steady. And then we then have a problem because specifically in the European context, the stages of assembly and manufacturing are quite stable and secured. But according to the Joint Research Center in 2023, in an analysis that they made with different clean tech technologies, we really have a problem on the global production, or the use share on global production is quite small and never been higher than 7%. And these disparities then have a very important consequence, which is a dependency on importation of raw and critical raw materials for these technologies. Unfortunately, electricity grids were not considered in this study, so the lack of data is even a bigger issue here. And then at the same time, we've seen efforts from the EU side to really tackle this within three key principles in mind. So on one hand, we have resilience and autonomy, which has been mentioned by the Farsight report, for example. We have the need for energy security, and we also have the principles of competitiveness and affordability, which have been put forward by the European Commission. And of course, they are very much interconnected. And At the same time, circularity then has been identified by us as one path to reduce dependency and insecurity, while also increasing this resilience, competitiveness, and affordability. And so far, the EU has actually been trying to put forward policies that try to increase this resilience. So we have seen, for example, the Net Zero Industry Act and also the Critical Raw Materials Act, which put forward targets to strengthen a EU-based value chain. And at the same time, this has been taking place by different files, but grids are a bit touch and go at the moment. For example, considering the Clean Industrial Deal, we do have the Grid Action Plan, which reaffirms the need for grid expansion and recognizes some of the challenges by grid supply chains. And the CAD, which looks into EU competitiveness through industrial transformation, also recognizes circularity as a key pillar. So really looking into how the raw materials can be put forward by the Circular Economy Act. And we also have a public procurement directives that's going to be revisioned in this year. And is expected to have the use of non-price criteria such as circularity, and at the same time, the Steels and Metals Action Plan, which hopes to help the sector decarbonize and integrate more circular measures. And looking into the Circular Economy Act, which is also to be launched in 2026, we have really this goal of putting forward a circular economy, increasing the circularity rate in the EU, which has been stagnant since 2010, so over 15 years, and they want to double it by 2030 to 24%. At the same time, they are considering measures to strengthen the business case for secondary materials and really putting harmonizing rules or improving recovery and facilitating the borders, cross-border flows. And of course, this should be aligned with different EU legislations. But what we want to bring really is that we have talked to different actors and really try to look into what is the status quo for electricity grids, as this is one really big important issue for electricity grids, and the demand for raw materials are increasing. So how can circularity support these challenges in supply chain and at the same time really increase resilience? And this means across different activities. So circularity is not only recycling, it goes beyond that. And today we are looking into one of the practices that look into the raw materials and closed loop, but is a broader concept that really can be implemented throughout the supply chain and the electricity grid life cycle. And this is a series that we are putting forward to really explain what is circularity and within electricity grids and how they can support such a resilience. So next webinar sessions will be published, and we look forward to see you in July, which will be published soon. So if you would like to, please keep in touch with us. But without further ado, I would like to then pass the word to Stefana, who will explain a little bit more about RTE's practice on closed loop aluminium and really seeing how this can be implemented into practice. Stefanie, the floor is yours.
Yeah, thank you, Natalia. So I will share my screen. Okay. So good afternoon. My name is Stéphane Heurtaud. So I'm working at RTE as a technical expert. So first of all, thank you to RGI for the invitation and for the chance to speak today. So my presentation is about the installation of a recycled aluminium alloy conductor on RTE grid. So the first slide, I will go quite fast to present RTE. So we are the biggest transmission system operator in Europe. So we have more than 100,000 kilometers of overhead line, more than 2,800 substations. We have also optical fiber and cross-border connection. Then here you have also in the presentation the financial data and the number of employees. Concerning the customers, so we have more than 1,200 customers. So it can be railway companies, market players, industrial consumers, power producer, and also the distribution company. Then our three main mission is to operating the power transmission system. The second one is to optimize the French electricity system. And the last one is to inform the public decision. So for this third mission, RTE publish quite a lot of documents. And so here I will just give the main document concerning the topic of circular economy. So the first one is the RTE Energy Pathway to 2050. So what we say is that there may be some tension concerning the mineral resource supply, in particular for certain metal. We speak also about the transition away from the fossil fuel that can create some need for new mineral resources and some supply chain issue. And we also have a different issue concerning the limited reserves, monopolies, conflict, etc. Then what also is important to say is that the topic is not only a topic for France and for the French TSO. So 5 years ago, 11 TSO firm a letter with their CPO to encourage contractors and subcontractors to protect the environment, also to contribute to the development of a more circular economy practice, and also to develop a global cost approach basing on life cycle costing. So this letter was 5 years ago. And then after this period, so this 11 TSO have worked together in sustainable procurement and circularity to share good practice and also to define some criteria. Then the last strategic document I wanted to share is our strategic development plan. So this document is available online. So you have the QR code on the presentation. And in this document, if I focus on two aspects, so the first one about the industrial effort, you can see that in France, like also in another country, in the next 15 years, in fact, we have plenty of work to perform on our grid. And this period can be comparable to the Trente Glorieuses, that is 30 years after the Second World War, in which we develop a lot our infrastructure. So today we are at the beginning on a very strategical period. And you can also see that on the second graph that our need will be increasing in the next 15 years. So it's about the industrial effort and concerning our environmental strategy. So in fact, we want to minimize our effect on the environment. And concerning the recycling and circular economy. So we speak about an objective concerning the incorporation of recycled aluminium in the new cable. So you can see this percentage. So it's the target we want to have in 2050. So that's for the referential document. So then I will present what we have performed. So some years ago, we made a first trial about overhead line cable circular economy. So the first step was to remove overhead line cable in the Maurienne Valley. So it was old overhead line conductor. So then we worked with the first partner, so MTB Recycling, that have decreased the conductor. They made also the separation between the different material, steel and aluminium, and they also cut the aluminium. Then we work with Trimet and Nicolas that is present today. So they perform quite a lot of tests to reuse this material. Then as we succeed to produce a new machine wire with enough quality, the machine wire come from Nexans who is making some overhead line cable, and their overhead line cable with recycled content. At the end, we install it on two new overhead line on our network. So yeah, at the center of the threads. So concerning this trial, so the conclusion, so the first conclusion is we managed to produce a new cable securizing the mechanical strength and electrical conductivity. Also, we noticed that if we want a new cable with recycled content, in fact, we need circular economy because we have to be sure about the quality of the aluminium we inject for electrical application. Also concerning this practice, so it's also permit to lower the emission. So recycled aluminium cuts tons of CO2 versus primary aluminium. And also one important point is that it's collaborative work. So we have all to work together on this topic. So we have the TSO, we have the recycling companies, the funders, and also the overhead line cable producers. So this were about the trial some years ago. And today I wanted to say more thing about the technical aspect. So the first one is about our TSO specification. So one important thing is that in France, in fact, our main technology that we are still installing on our network is a triple AC cable, saying that we use aluminium with another element. It's an aluminium alloy, so this material, in fact, is less sensitive to the introduction of some impurities. And then on our specification, we refer to international standard. So in fact, we want to have mechanical, electrical, and also thermical properties. Concerning the electrical properties in our specification, so we put some maximum value that we do not want to go above. So it's a maximum resistivity. We have also some tolerance in the wire diameter that can introduce some solution to the suppliers. And concerning the mechanical properties, we have some minimum specified values. So we speak about tensile stress and also minimum elongation. So that's about our specification, what we ask for the new cable. And then if we focus more on the overhead line cable quality. So one risk that can be present is that using recycled materials, in fact, you can introduce some impurities, some non-aluminium element. And these impurities can, at the end, or increase the resistivity or reduce the mechanical strength. So we have worked a little bit on this risk. So today what we say is that in fact suppliers have different possibilities to be conform with our specification and to adjust to the overhead line cable properties. So in fact they can select the material. So this criterion can be recycling dependent, but not only because one supplier can also choose maybe some wire machine with better properties. So we say there is also some existing tolerance in the standard concerning the cross section. So you can work on the cross section to achieve the electrical or mechanical properties. And you can also perform some additional heat treatment to be okay with the specification. We also look at our quality data we have for the overhead line cable production. So we ask for our suppliers. So this data is not only for one supplier. So we make a mix of different suppliers. So what we see is that each production, in fact, meets RTE specification for electrical and also mechanical quality. So we verify with resistance measurement. In fact, we have some mean value quite below the maximum limit. So we see that on the production we make for RTE, in fact, the cable are quite good and quite below the maximum value, and we have quite a high to standard deviation. So we can say that in fact there is some existing margin between the quality of the cable we buy and the cable specification. So for us, when we speak about circular economy and the fact that we introduce some recycled materials, in fact, we think that suppliers have different solutions to mitigate this possible negative effect of recycled materials to ensure the cable's quality. So then the conclusion, so circular economy on aluminium, in fact, first is a way to reduce the European material dependency on aluminium. So it's quite an important point. Then it also have a beneficial effect on CO2 emission. Concerning the technical specification, so we have seen that we can reach our technical specification using recycled content. And we also want to underline that this practice can be done with a collaboration across the value chain. So we need all the different industrial partners in the value chain. And then as the time is running out, maybe I will be quite fast on the last slide. So the next step will be to strengthen the supply chain resilience, to accelerate the circularity, to build industrial and recycling capabilities, and to foster ecosystem collaboration with different topics on which we can speak during the chat if you want. And thank you for your attention.
Thanks a lot, Stephanie. And as I mentioned before, if not everyone was here before, we'll have the time for you to share your questions at the end. But now I would like to invite Nicolas Achineau from Trimet to share a little bit of his insights from the aluminium sector. Nicolas, the floor is yours. Nicola, I think you're muted.
Yeah, sorry, I was on mute. Let me share my screen. I cannot see it right now.
If you like, I can also.
Yeah, no, that's fine. I will.
Yeah. Okay.
All good. So good afternoon, everyone. Thank you for inviting me to present the perspective from the aluminium producer. So I'm Nicolas Archenot.
Nicola, just a small problem is that we see only the presenter's view on your screen. I think you just have to switch the.
It worked well before. That's always.
No worries.
Sorry for this. Is that better now?
It's still the presenter's view. I think you just have to switch the display. So normally it's in French, so I'm not sure, but normally you can see it in there normally. Yes.
All good.
Very good. Perfect.
Should be fine. Yeah. Okay. Sorry for this. So yes, so I was explaining. So I'm the procurement, supply chain, and sales director for Trimet France. First, quick introduction of who Trimet is. So we used to be. So we are a very old company, established in 1907 in France. Former Péchinet, for those who knows, and then Alcan and Rio Tinto. And then Trimet took over the company in 2013, which is a family-owned company and a key player in the aluminum industry in Europe. Since, as you may know, with the energy crisis that we've been through over the last few years, there are not that many smelters, aluminum smelters in Europe, and now we are one of the biggest one. Trimet France is so we have two sites. The biggest one is in Saint-Jean-de-Maurienne. We have 620 people working there, and we are producing 150,000 tons of aluminium per year, mainly from primary aluminium, as I explained before, from which 90,000 is dedicated to aluminum wire rod, which makes us one of the key actors in Europe, supplying most of the cable makers in Europe, mainly in Europe. Since over the last 30 years, and we have long-standing cooperation with them. We know them very well. We are also in connection with different TSOs, and that's how we've been involved into this experiment that Stefan explained before. So if we look at the strategy challenges for us, obviously, as you know, and also Natalia, you explained some of this before, there is a real topic about the industrial sovereignty, with currently Europe importing more than 30% of its needs in aluminium wire rod. And this coming mainly from Middle East, and that's why currently we know that our customers are in some difficulties to get their material, which reinforces this topic. And as you said also before, aluminium has been classified as a critical metal, which put us also into a need to work to try to increase our capacity and production. Obviously, there is a challenge around the energy transition. Also, Stefan explained the significant investment which will be done by most of the TSOs in Europe, which we can see already in some requests that we have some of our customers to see whether we could also improve our supply to them in the coming years. And there is obviously a topic of decarbonization. with some environmental criterion which had been put in the different bids to the cable makers and also to us then in terms of aluminium production. So we have the chance being in France. Being in France, most of our energy is supplied by nuclear energy. So in terms of carbon footprint, we are one of the best. And but we don't want to stop from this, and that's where we were very interested into looking at the possibility to increase to look at recycling content into aluminum rod, which has never been done in the past because of the different things that Stefan explained about conductivity and so on, and also the difficulty to capture this kind of scrap, which would be which we can use in aluminum production for wire rod. So that brings me to the technical challenges that we had to face. So there are different steps, and on each step there are some challenges. The first one is about the waste management and upfront, and that's where we've been in contact with some recyclers really dedicated to cable recycling. Because we realize that looking at the different alloys that we can use into wire rod production, more or less only the scrap coming from cables dismantling or from cable makers production, let's say their scrap from production, can be used into our process. That's where we had to work a lot on the traceability and to ensure that we have a reliable supply. So we implemented quite a strong quality check upfront with different recyclers to ensure that they can provide this kind of product. Then obviously when we receive the material, we have a check on composition, because depending on the quality of each deliveries, and we may or we may not be able to use it. And even if we may be able to use it, the different quality of the aluminium received, even from the cable dismantling, can be very different. We could see from the small volumes that we receive from RTE, for instance, that from time to time we have different metal with not the same quality of, for instance, some side material like silicon, magnesium, and so on. And obviously, all this will have an impact at the end on the conductivity. So then there is a topic about the inclusion quality. That's where we minimize inclusion, increased our process control. And this also has an impact on our casting possibility, since our furnaces that we use to produce wire rod was only coming from aluminium from primary, which was meaning that coming from the electrolysis at already 900 degrees, and increasing the recycling content has an impact on the furnace capacity to follow the speed of the wire rod, the wire rod mill. And also this have an impact on the different conditions for casting and rolling coming from this recycling content. And at the end, obviously, because that's something which remains, let's say, a prerequisite, we cannot mitigate on the electrical and mechanical properties, and we didn't change at all the specification. Meaning that whether we'll deliver some wire rod to the cable makers with or without recycling content do have exactly the same respect in all all properties for electrical and mechanical. So there's no, let's say, mitigation on this to ensure that at the end the cable is exactly the same properties. So that's the different technical changes we had to go through for this experiment and also over the last years. And now if we look at the next step, what is important to us is really to move from this prototype stage, I would say, to really industrial implementation, which we already did. And over the 2 years, with an increase of some sales for railroad recycling content to our customers. For this, we have to work upfront on the value chain to ensure that we get the material, because this scrap coming from mainly from the TSOs are of a very high quality, can be used by anyone, and has a very high value. And it used to be even exported to some other side of the world, like for instance, US currently with the tax from Trump, but also in Asia and so on. And that's a key challenge to keep this material in Europe and to leverage this kind of collaborations to keep the material and then to increase our volumes in the coming years. Then we have to work on our own production capabilities. I explained before that our furnaces so far and rod mills was mainly adapted to rod mill to electrolysis, metal coming from electrolysis. This recycling content has an impact, and we have to invest for this to be able to follow the rhythm. And not only on the volumes, but also on increasing the recycling ratio. For instance, Stefan was referring to 30% recycling ratio in terms of volumes they would be able to supply from their own. But for us, it will be a challenge for the reason explained before. So we have to look at this. For the time being, we are more at 10-15%. And then, as I explained, to really work upfront with the upstream supply chains to prevent the added value loss, because when it's all mixed by the recyclers and so on, the material is always losing value. And if we want to optimize either the volumes or recycling ratio, we need to ensure that the supply chains upfront from the recyclers really do it properly, separate the materials, the different quality, and so on, so that we really can optimize this value add. That was about it for me. It was quick. Don't hesitate to ask questions within the Q&A. And again, thank you, Natalia, for the invitation.
Thanks a lot, Nicolas. And now we'll go to the Q&A session. So I already see 2 questions on the chat. So the first question is from Christian. Are there standardized technical specifications and certifications established for circular recycled aluminium? So that I think either Nicolas or Stephanie.
I can answer one of it. Specification, as I said, is exactly the same. So we respect exactly. So there's no change on this. And in terms of certification, for the time being, we asked a third party to qualify our overall process, so we can certify, for instance, the recycling content. And also what we did, we worked with the cable makers about the emission of special EPD, environmental product disclosure, for our 2 lines of product, being the conductors, the pure aluminium wire rod, as well as for the Almelec, which is the magnesium silicon family.
Perfect. Thanks a lot, Nicolas. Stephanie, do you want to comment?
No, I think Nicolas answers the question. Maybe what I can say is that for RTE, in fact, we are performing some circular economy on an industrial way with some supplier, and we have the same technical specification for overhead line cable with and without recycled content.
Okay, perfect. Thanks a lot. So I do see a lot of questions coming in. I'll go to the next one on the line. And if anyone would like to also speak up, feel free to raise your hand, and you can also speak up your question. So the next question is from Sarah. How many times can a cable be recycled, to Stephanie?
Indefinitely.
In fact, I think cable can be recycled a lot of time. There is not a limit, but at the end, for all TSOs, cable lasts some decades on the network. So in fact, I think, unfortunately, we would not be present a lot of time for the recycling.
Yeah. And if I can just complete on this one, as I said before, it's all about the composition of the aluminium that we will receive, which will make our ability to recycle it or not. So for instance, we receive some lots from time to time where the quality of the metal was not as good enough to recycle it in wire rod. So we use it for something else, but not for wire rod production. So it can be recycled indefinitely until we respect this chemical composition.
Perfect. Thanks a lot to the both of you. And I think the two next questions are a bit on the same line of thought. So Valentina Schiffer asked if there are any economical benefits. And then Anna from UNEC asked about financial indicators of the recycled cables. She also asked if it was hard to tell at the prototypes stage, so if there is a difference where scaling up. Then I'll pass the word first maybe to Stephanie, and then there's also a question for you, Nicolas.
Yeah,
so basically,
I can start the answer. So, in fact, yes, there is some beneficial effect for economy, because we say that circular economy is also a way to secure the material supply chain. So some years ago, we have some difficulties to buy some aluminium. So yeah, it can have some beneficial effect. And on another part for the TSO and RTE, so the trial, this prototype stage was end 3 years ago, and so since this trial, we start to scale this experiment, and so we work with all our different suppliers to make more circular economy.
perfect.
And from
Nicolas?
our perspective, on the financial side, it's always tricky about scrap, because the thing is that, as I said, the scrap coming from cables is very, very good quality for all other competition. And that's where you have some people who want to increase their recycling content for other production are ready to pay even more than from aluminum coming from primary metal, just because they want to decrease their own CO2 emissions and so on. So there's quite a high competition on this specific product. And I cannot tell, for instance, that buying this kind of scrap on the market to use it into our production will have a benefit in terms of the financial impact.
Perfect. Thanks a lot. And then Anna also asked you about the stakeholders, if you can elaborate a little bit more on recyclers.
This one is for me, or?
Yes, for you. Sorry.
Can you repeat the question, please, to be sure?
Yes. She asked, you mentioned these stakeholders, grid operators, cable makers, recyclers. Can you elaborate on the latter?
Yes. The thing is that I don't know how, for instance, RTE used to work in the past for the dismantling phases and what the cables was coming. And that's where there is some work to be done to ensure that from the beginning, the material, the cables doesn't disappear and then goes into other processes where you're just losing the material. What is very important is that from the beginning, these key actors like MTB, we spoke before, or also we know Recicab, for instance, they really take the ownership of this cable straight from the beginning. They can transform it, and that we don't lose the value and it doesn't disappear. And that's where this work has to be done all together with the TSOs, with the recyclers, with us, to ensure that this loop remains closed and the material doesn't disappear. Otherwise, once it's gone, it's gone. You don't see it again.
Yes, just to complement, I think this was also one of the key takeaways that we added to our statement on the Circular Economy Act, because for grid specifically, it's really important that the high quality material remains there and not goes to some other sector, which could probably use lower quality metals. And on the ownership, actually, the next question also goes with it. So Vincent Dufour from Elia asked how to organize the ownership of the scrapped aluminium conductors in a closed loop. So maybe I'll pass to Stephanie, and Nicolas, you can also complement.
Yes, so in fact, after the experiment, we scaled this breakdown, in particular with one supplier, and with the juries for all part, we work on the best way. So there was different option. So the one option that it was that as a TSO, we keep the ownership quite to the end. And finally, what was the most common and easiest way for contract aspect was to give the ownership to the recycling company. So after the demand studying, in fact, as a TSO, we are not more owner of the material.
But with, if I'm not wrong, with the constraints to him to sell
So
it
on
to us or to
that's
the
it.
aluminium producer.
Because in fact,
Otherwise,
in fact, what is very important is not to focus on one part of the value chain and to have in mind all the circular economy and to organize it on one way. Yeah.
Perfect. Thanks a lot. Then Christopher Richon asked, how do you plan to scale this experiment?
So what we have done after this experiment as a TSO, for us it was a succeed because on a very small projects, so we have seen that we can manage to do circular economy. And so then we know that in the next year we will dismantle quite a lot of overhead line cables. So we will have all the aluminium that will be available on another part. As I have present, we have quite a huge of demand of new overhead line cable. So we have seen the way on which we buy our overhead line cable. And so we try to work with all our suppliers on that topic.
And from our side, so we used to work with some other grid operators, and we have already moved to a much larger scale. So we have more than 20,000 tons last year sold of wire rod with recycling content. So it has already moved from our side.
Great to hear. And then actually 3 different people asked how limited this is to specific cables. So if it's only on the triple AEC cables, or if other types of cables such as underground, submarine, or even other voltage types will be possible. So maybe I'll pass to Stephanie and then Nicolas.
Do you want to start, Nicolas? Maybe we'll be more precise.
For us, we have 2 different, as I said, 2 different brands of aluminum wire rod. Then can be used in 2 different applications for cable. When it's pure aluminum, what we call conductal, this one is more difficult. We can only use the same quality of scrap. And that's where we are. That's where the relationship with the recyclers and the TSO is very important, because we need to know this quality. The other one, the Almelec, this one is more. It's easier to recycling because we have some conductivity requirements lower and so on. So this one is easier to deal with to increase recycling content. But for us, that's 2 different products. So we can use scrap from conductal to Almelec, but the other side is not possible, which limits the ability to increase recycling content into conductal, for instance, the pure aluminum.
Okay, I can complete saying that RTE has some experiment also to try circular economy on underground cable, but in fact for industrial point of view, what is more complicated also if you want to take an old underground cable, in fact sometimes in the project we do not extract the old cable, so we have also some problem of availability of old underground cable, so it's also difficulty.
So for the dubbing, with RTE, it's mainly Almelec for overhead lines. Yeah.
Yes, looking also on the offshore side, I imagine that could be a bit create disturbances within the ecosystems. So it's also a matter of fact of looking to the end of life and what case by case would be the best. Then the next question we have on the chat is from Davy, and is actually a broader question looking to the circularity approach as a whole. So looking into the whole system, they posed the question if it would be better for a conductor to be recycled into an aluminum beverage can. So basically a can that can be done many, many times instead of only on a cable. And I think it's maybe a bigger question of the lifetime of a conductor is a life of 40 years, and a can is a bit less. But then I think one of the points that you both made on the industrial ecosystem, right? There is a supply chain, whereas there are prices going up. And in the end, the grid tariffs also rely on those prices. So it's also a matter of the whole system. But maybe you have something else to complement.
Yes, maybe we can say that Nicolas speak about this before, but what we want to avoid is downcycling this aluminium, because
Exactly.
the aluminium from electrical application is quite pure. So in fact, if we use it for aluminium beverage, in fact, we do not need such purity. So I think this point has also to be taken into account.
Yeah, and obviously coming back to the financial aspect, the producer of aluminium for can, for instance, they will never be ready to pay such level of price because it's really too high. Because they would be able to find some other scrap much competitive on the market. And where on the other side, for us, we have no choice. Only aluminium coming from the cables can be used. So if we want to increase recycling content for cables, that is the only way to capture this scrap and not another one.
Very good points. And then we have Stuart Miller from Scottish Power Energy asking about the cost difference between recycled and non-recycled content. Do you have any specific numbers that you were able to share at all?
Tough.
It's a nasty question.
But I did say, I will not say numbers, but I did say that people are ready to pay more for this kind of scrap than for primary metal. So that gives you an idea on the fact that if some people expect that since it's recycling, it would be cheaper, it's not true for aluminum, at least for this kind of aluminum.
I think it's a matter of the whole ecosystem instead of looking only on the specific cable, as Stephanie mentioned about the aluminium constraints. Stephanie, do you want to complement?
No. In fact, I cannot give some data on that topic. Sorry.
Yes, I imagine that doesn't hurt to ask. So Simone from Tenet also mentioned the triple AC cable with Almac is being used. And she also mentioned that their standard is on the AL7. And if this would also be possible to have this 10 to 15% recycled content or not.
What is it made from, Stefan, this cable? I'm not sure about the aluminium.
Or if Simone wants to also.
So I have a problem of connection. So
the standard that she's mentioning is AL7 for the triple AC conductor.
Maybe what I can tell is we supply the whole range of aluminium wire rod for cables, more or less. And for the time being, there's not any that we could not at least reach the 10% recycling content. For the pure aluminium applications, there might be more than 10%. At 15%, we start to be at the limit. But again, it depends on the quality of the scrap we will receive. But
Perfect.
for the time being, I didn't see any, let's say, constraints on this. For Almelec, for us, the 30% is achievable. For Conductal, I don't think it will be.
Perfect.
And also one difficulty when we work with old overline cable from RTE is that at RTE the end of life of the cable is quite old. So the cable we give to Trimet is some cables that can have 80 years old. And in this time, the aluminium company has not the same quality than today. So we know that also for what we expect to be pure aluminium, in fact, we can have a lot of another element. So it can complicate the recycling.
And that's where we can use the benefit of our own electrolysis with primary metal, because depending on the quality of the scrap intake, with older cables and so on, with not having the same chemical composition, not as good as what it is recently, what we can do is to select our pots in our electrolysis to get the pot with the better quality aluminium to mitigate the effect of the impurities that we will find of the scrap. And that's our benefit of our own electrolysis, and to use this to adapt the chemical composition and at the end fulfill the chemical composition required.
Okay, perfect. Then we have a question from Anna. What do RTE and partners undertake to increase traceability of secondary raw materials, or rather waiting for the regulatory changes? I'm guessing for Stephanie.
Yeah, I think in fact regulatory changes will help to increase traceability. But if not, yeah, I think that Nicolas gives the answer before, so we can have some traceability today. Yeah.
Very true.
If you want to complete, Nicolas.
No, that's what I said before. In terms of traceability, we'll put in place what we need to internally to be able to supply to the information to anyone.
Then we have a question from Statnet about the wires drawn from recycled rods, if they are more prone to fatigue or mechanical stresses. I'm guessing this is also kind of answered by Stephanie, but if you want to complement Stephanie.
Yeah, it's a good question. In fact, we focus on the technical specification, but it's true that some impurity can also affect the aging. So on the scientific papers, I know that I think it's from Denmark, they study the effect of copper on the corrosion, on the susceptibility to corrosion. So we know that some element can have negative effect on the aging. But in fact, for me, what is important is that adding recycling content at the end, what we do, we focus so on the technical specification, but we also look at the composition of the wire, and so we know that there's some point on which we have to be careful. But also for cable without any recycling, in fact, the problem also exists. So yeah, don't think it's only a subject for circular economy.
And from our perspective, I don't think regarding chemical composition due to the scrap and so on, there will be an impact. The only topic might be coming from impurities, as Stefan said. And in regards to impurities, on our round mill production, we have what we call courant Foucault detection to identify if we have some impurities, which can come from scrap, but we can also come from our internal processes. So that's something we are used to follow. And our control plan is the same for rod with or without recycling contents, which means that we don't tolerate more impurities, whether it is with or without recycling. What is very important is that when the cables are recycled by people like MTB, for instance, we need to ensure that the recycler is very good at separating and sorting the material. Because usually you can have some copper, for instance, into this cable recycling, and really must make sure that we don't have this copper coming into the scrap, because that's where the issues may come in. And to be very honest with you, when we have some claim with those people, the recyclers, that's more or less only about this topic, about the fact that there might be some like a copper or iron or these kind of things into the scrap, which for us creates huge problems into our production, but we can see it with our internal processes.
And then also, yeah, concerning the fatigue failure and the conductor galloping, what is important then as a TSO is the mechanical dimensioning we make on the overhead line, because at RTE, in fact, we do not have conductor galloping because due to the span length and also the tension we put on the cable, because our cable has quite a high value of mechanical tension. And concerning the fatigue failure, in fact, if we use good fittings on our experience, but with a cable without recycling, we do not notice any failure in the last 2 decades.
Okay, perfect. Thanks a lot, Stephanie and Nicola. And then there are 2 questions still. So from Hakshinen, they're asking about whether the impact of primary aluminium has been modeled or studied versus the recycled aluminium. And I'm guessing this is more of a question of a life cycle assessment, which I am aware that RTE has done that. So can you share a little bit of that, Stephanie?
Yeah, in fact, we performed some model and calculation. So maybe I did not present that today. And in fact, yes, we have seen that using recycling, in fact, we save some carbon emission. So yeah, it's true.
Yes,
And
and I
then
can.
also it depends if you want to have a quantitative value. It depends also. It depends with the primary aluminium you are working with, because some producer maybe make more emissions than others. So the calculation can be quite complicated. But
But
Nicola, have you?
overall an ID, you would have the same proportion of savings on the CO2 emissions by the component you will have as recycling ratio. But the benefit is not only on CO2 emissions, but also on energy consumption, because it's not a secret that primary aluminium production is a high intensive consumption. And we estimate that remelting scrap is 5% of what we would have for primary aluminium. So even if it's on a small proportion, that's still this proportion which is not produced from primary metals that we would save for energy. And as I said, also on CO2 emissions.
Perfect. Thanks a lot. Then we have a question about birds, if they're safe from electrocutions from this type of cables. And looking as the composition is the same as the normal cables, I would say no. But if Stephanie and Nicola, do you have anything to add on that?
Yeah, in fact, it's a topic and on that subject, so the birds save, we use some fittings we install on the overhead line to avoid the electrocution. So we have some solutions that are already qualified to avoid it, and we also work with some suppliers on new solution to have to be most effective on this topic. But in
And
fact,
this,
there is no difference between a cable with and without recycling on that
Yeah,
question.
no. So I don't know anything else.
No.
But we do have a lot of content on our website about bird protection, so I would suggest them to have a look on the other webinars. And also on the other question, I can share the previous webinar on circularity, which RT from 2024, sorry, in which RTE actually shared their whole strategy on life cycle assessment. And the last question, also from Tenet, from Simone, do you have information on how much emissions are avoided on the recycled content versus non-recycled? And if the recycling process also produces extra emissions? I think we've sort of covered, but if you have any specific numbers.
I can tell at least for the aluminium component. As I said, for instance, our aluminium is 5 tons of CO2 mainly from primary. Is close to 5 tons of CO2 per ton of aluminium produced. What we could see from the 10% is that we switch from 5 tons to 4.6 or something like that. So it's not a direct impact of 10% because you always have some additional consumptions. For instance, as I said, since we put some cold metal into the furnace, we consume a bit more with this furnace, but we save a lot on the metal not coming from electrolysis. But to have an idea, let's say if it's 10% recycling content, it's a bit less than 10% of savings on the CO2 emissions. And that would be proportional, meaning 20, 30%, more or less the same. But it's always a bit less.
Perfect. Thanks a lot, Nicola. Stephanie, do you have anything to add?
No, I think Nicola answers the question.
And this has been also verified by EPD, as I said, EPD and LCA. We did a life cycle assessment with or without recycling content, and we put everything into our model to get the impact. And these numbers I'm giving you are validated and certified by third party.
Perfect. Maybe if there are any other questions, the participants can write on the chat. We still have a couple of minutes. So maybe one question from my side. Stephanie, from RTE side, has this prototype, this practice impacted the public procurement on RTE? So have you now increased the mandatory requirements for recycling or put any kind of voluntary recycling content on the cables itself when procuring?
Yeah, so I did not catch the entire question because I have some problem of connection, but I have listened that you were wondering about the next step after the experiment. So in fact, concerning the procurement to buy new overhead line cable at RTE, we have some long-term contract. So after this experiment, we wrote a letter to all our suppliers informing about this experiment and saying that we wanted to work on that way with all the different suppliers. So after that, we have some very interesting meeting with the different suppliers. Maybe there is some suppliers present today in this webinar. So with some suppliers, we succeed to change the contract to do circular economy on the present market. And then we are waiting the next framework market to maybe add this topic on our specification.
Okay, perfect. Thanks a lot. And as I do not see anything else, maybe we can then close off, and I'll give you, the two of you, some time if you want to add anything or mention any other solutions or challenges to the practice.
No, thank you very much for the invitation, for presenting, and also for all these interesting questions. And yeah, if you want to speak about this topic, do not hesitate.
Yeah, and for me, I'm really more than happy that you invited me because you know, it's not always easy. It's quite uncommon to get in contact with, because RTE is not our direct customers. There are some cable makers in the middle and so on. And if we want things moving, the only way is to have this kind of session where we can explain to the TSOs what they can do on their own, what they have in hand to be able to make things changing, because without them, it will not change. If we keep the same way that we've been doing it over the last few years, we'll have the same results, and we will not capture the full value of this kind of opportunity, which, to my opinion, is a real opportunity to save material, to get the metal, and so on. And so thank you very much for that. I think it's very important.
Thanks a lot to the both of you, and thanks a lot to everyone who joined us today. Just sharing a bit of information. So one thing is that the RGI Grid Awards submissions are open. So if you have any practice that work with circularity or other innovation within grid supply chains, please feel free to apply. The deadline is 5th of July. And then also sign up for our RGI newsletter to stay updated. As my colleague mentioned in the chat, the presentation and recording will be available public on our website. And as I mentioned, we'll have next sessions published in our website and the newsletter soon. So stay tuned, and we'll see you on the next time. Thanks a lot.
Thank you.
Thank you.